In this video, we are going to expand a few polynomials using Pascal's triangle. So usually once on a page, if I need to, I write Pascal's triangle out so that I can just reference back to it. You can do it each individual problem and stop where you need to. It really doesn't make a difference in the grand scheme of things. But Pascal's triangle always starts with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and then I'll go 1, 6, 15, 20, 15, 6, 1. This is my x, that's a terrible arrow. Starting off with my x to the 0th row, x to the 1st, 2nd, 3rd, 4th, 5th. This last row is my x to the 6th. When I say x to the 6th, I'm referring to anything in the parentheses. That exponent here is a 6. So I'm going to have coefficients of 1, 6, 15, 20, 15, 6, and 1. That I just get those numbers straight across, and now I have to fill in the variable portion. So I take the very first thing in the parentheses, which was an x. I'm going to have an x to the 6th, x to the 5th, x to the 4th, 3rd, 2nd, 1st, 0th. Then I take this thing here, which is a positive y. I'm going to have a y to the 0th, y to the 1st, 2nd, 3rd, 4th, 5th, and 6th. And in this case, everything was plus, so I'm going to just have plus in between everything. Now, I'm not finalized here because the y to the 0th and the x to the 0th become 1. I'm just going to end up with 1, 6, x to the 6th, plus 6, x to the 5th, y to the 1st, plus 15, x to the 4th, y squared, plus 20, x cubed, y cubed, plus 15, x squared, y to the 4th, plus 6x, y to the 5th, plus y to the 6th. Okay. I did that problem in a slightly different way than I did the previous video, where previous video I did all of the first term, all of the second term, and so on. There are different ways to do the exact same thing. Once you write it down, no one's going to be able to know which one you did. So pick your favorite. Now, 23 is going to get a little bit messier. Okay, I have this 3, which means I'm going to be in this row, which is nice. But these terms are a little bit different. So I still get to start off with, in this case, 1, 3, 3, 1. But now this first term is a 2x. So I'm going to have a 2x cubed, a 2x squared, a 2x to the 1st, and a 2x to the 0th, all in parentheses. Okay. Now I have a minus y squared. The minus is going to be what makes this different in a little bit. But I'm going to have a y squared to the 0th, y squared to the 1st, y squared to the 2nd, and a y squared to the 3rd. And the last thing, everything was plus all around. Here it's not, so I have to kind of think through what's going to happen. It's going to follow a nice pattern. Math likes patterns. If I were to do the first times first in just a foiling sense, the 2x times the 2x is going to give me a positive, because a positive times positive. I multiply it by first again, I get a positive. So my first term is still positive. But after that, I'm just going to start alternating, okay? I'm going to have a plus, minus, and a plus. I started at the wrong spot when I was writing. Sorry about that. I'm going to have a plus, a minus, a plus, and a minus. This leading plus I don't need to write, but they're just going to alternate, and we need to think through why this is going to make sense. The end term, if I'm foiling last times last, I would have a negative times a negative, which is a positive, times another negative is going to give me a negative, which is why we have this negative right here. The stuff in the middle is just going to alternate back and forth. Every time we multiply by another binomial, one of those terms gets multiplied by a plus, one gets multiplied by a minus. The next time, they're just shifted down the line a little bit. So I'm going to have the positive thing multiplied by a negative thing, which makes it negative. And then I'm going to have the negative multiplied by a negative to give me a positive. Okay, so they're just going to shift. So now I have that positive 1, which is great. My 2x cubed, I need to remember how my exponent rules work. This is 2 cubed, which is 8x cubed. My y squared to the 0 is just a 1. Minus 3 times 2 squared is 4. X squared is x squared. Y squared to the first is y squared. Plus 3 times 2x times y squared squared is y to the fourth. Minus 1 times, well, 2x to the 0th is 1. Y squared cubed is going to be y to the 6th, if I get those in appropriate colors like I thought I did. Okay, now we're still not done, but we've done all the heavy lifting. Now the variable parts are done. I just have to multiply the coefficients together. So 1 times 8 times 1 is 8, x cubed stays. Minus 3 times 4 is minus 12, keep the x squared, keep the y squared. 3 times 2 times 1 is a plus 6, keep the x, keep the y to the fourth. Minus 1 times 1 times 1 is minus 1, keep the y to the sixth. And that should be my final answer. These are the more annoying ones because you had a negative sign in there and you had an exponent inside the parentheses that then got raised to an exponent. Those are the only like tripping points that they're going to be. Otherwise, you're basically just copying down what Pascal's triangle tells you to do. Have a great day, everybody.